Welcome back, students. We'll be looking at section 4.3, practice problems for solving systems of linear equations by elimination. So remember, we're going to use the elimination method to find our x and y values in an ordered pair form. All right, so looking at number 1, the first step was to make sure that our equations are in the ax plus by equals c form. Both of them are in that form, so we don't have to adjust them in that way. We can go straight to step 2. So I'm going to rewrite my equations here. And I'm going to reevaluate them to see if I need to change anything about them so that one of my variables will cancel out. I notice that my y's have a negative y and a positive y. And so I don't have to change anything. I can actually just add these equations together and the y's will cancel out. So I have 3x plus x gives me 4x. The y's cancel out and become 0. Negative 12 plus 4 becomes a negative 8. I'm going to rewrite down here and actually find my x value. Divide by 4 and I get x equals negative 2. Now I'm going to use that in one of my equations to find my y value. It doesn't matter which equation you pick. You can pick either one. I'm going to pick the second one just because it has less values and it'll be simpler. Plug in my negative 2 for x. Add 2 to both sides. And I get y, let's see, 0 plus y equals 6. So y equals 6. It looks like I have my two values, so I'm going to put them in my solution over here, negative 2 and 6, but I need to verify, I need to double check. So 3x minus y equals negative 12, 3 times negative 2 minus that positive 6 equals negative 12. I get a negative 6 minus 6 equals negative 12. I'm going to do my keep it, change. And end up with negative 12 equals negative 12. So that works out so far. Let's check the other one. X plus y, got my plus sign, equals 4. Replace the values. And we get 4 equals 4. So we have, in fact, done that one correctly. Number 2. All right, so again, we need to check and see if we have it in the ax plus by equals c form. We don't. So we need to adjust actually both of these. So I'm going to start with the first one. 5x equals y plus 5. I can subtract y from both sides, and that'll move it over to that same side as the x on the left. So that gives me 5x minus y equals 0 plus 5. So this equation becomes 5x minus y equals 5. This is what we will use when we get to step 2. Now we need to do the other equation. 2y equals 5x. I'm going to subtract 5x from both sides. I get negative 5x plus 2y equals 0. This is the equation that we're going to use for the second one. So now let's start step 2. I have 5x minus y equals 5. I also have negative 5x plus 2y equals 0. Now I'm going to check and see if there's anything I need to adjust so that I can cancel out one of my variables. I noticed that my x values, one is a positive 5, one is a negative 5. So they'll actually cancel out if I add these two equations together. I don't need to adjust anymore. So I'm going to do that. I'm going to add them together and get 0. Negative y plus 2y becomes a positive 1y. And then 5 plus 0 is a 5. So we end up with y equals 5 for this one. Now I need to take that value and plug it into one of the equations to find the other value. I'm going to use that first equation, the 5x equals y plus 5. Replace my y with 5. I get 5x equals 10. Divide both sides by 5. And I get x equals 2. I now have my two values, but we need to check them. So I have 2, 5 in parentheses. Don't forget the braces, because this is saying this is our solution set. That's what those braces mean. Take my first equation, 5x equals y plus 5, and replace those values. I get 10 equals 10. So yes, that is correct. Now we'll double check the other one. And again, I get 10 equals 10. So we are correct in our answer. Number 3, we have x plus 3y equals 19, 2x minus y equals 10. They are both in the ax plus by equals c form, so we don't have to do anything with that. So I'm going to go ahead and move on to step 2. X plus 3y equals 19, and 2x minus y equals 10. All right, at this point I need to figure out, do I want to cancel out my x's or my y's? Neither one of them have a matching partner. So I need to figure out, do I want to adjust my top equation so that I can get rid of my x's, or do I want to adjust the second equation and get rid of my y's? I'm going to pick getting rid of my x's. So I'm going to multiply this top equation by a -2. And the reason it's a -2 is because I need an opposite sign 2 so that my 2's will actually cancel out. I end up with -2x minus 6y equals -38 because I have to multiply that -2 through the whole thing. And then I'm just going to rewrite my other equation here because we didn't change it at all. My x's cancel out and I get 0. -6y plus a -y is a -7y. And -38 plus 10 is a -28. Go to step 3 and solve for y. So I'm going to divide both sides by -7, and I get y equals 4. Now that I know my y, I can plug it into one of the other equations and get my x. I'm going to choose the first equation, x plus 3y equals 19. X plus 3 times 4. So x plus 12 equals 19. Subtract the 12 from both sides. I get x plus 0 equals 7. So that's x equals 7. I have my two values. So I have brace, and then within parentheses, 7, 4, parentheses, and then brace. And I need to check my answers. X plus 3y equals 19. So 7 plus 3 times 4 equals 19. 7 plus 12. And that is 19 equals 19. So that one checks out. Let's check our other one. 2 times 7 minus 4 equals 10. So that's 14 minus 4 equals 10. 10 equals 10. And yes, we do have the correct answer. Number 4. 4x plus 3y equals -28. And then we also have 5x minus 6y equals -35. They're both in the proper format, so we don't have to change anything there. So I'm going to rewrite them over here. So I have 4x plus 3y equals -28. And then 5x minus 6y equals -35. All right. After I evaluate my x's and my y's, I noticed that to get my x's to match, I would need to multiply both equations. But to get my y's to match, I would only need to multiply that top equation because 3 and 6 are both factors of 6. So that's what I'm going to do. I'm going to multiply my top equation by a 2 so that that 3 will become 6y. So I end up with 8x plus 6y equals a negative 56. And then rewrite the other equation. All right, add these equations together. 8x plus 5x gives me 13x. The y's cancel out and become 0. Negative 56 plus a negative 35 is going to be a negative 91. Go to step 3. Divide both sides by 13. And I get x equals negative 7. Take that value and plug it into one of my two equations. So 4x plus 3y equals negative 28. 4 times negative 7 plus 3y equals negative 28. All right, I get negative 28 here plus 3y equals negative 28. I'm going to add 28 to both sides. End up with 0 plus 3y equals 0 because the 28's cancel each other out. 3y equals 0. Divide both sides by 3 and I get y equals 0. So our solution set is the ordered pair negative 7, 0. And we need to check our answers. So 4 times negative 7 plus 3 times 0 equals negative 28. Negative 28 plus 0 equals negative 28. So negative 28 does in fact equal negative 28. And that one is good so far. Check the second one. 5 times negative 7 minus 6 times 0 equals negative 35. Negative 35 minus 0 equals negative 35. And yes, this one is also correct. So we are good. Now let's look at number 5. On number 5, it's the exact same problem, you'll notice, as number 4. In number 4, we chose to get rid of our y's. In number 5, I want to get rid of our x's, just to show you that it will work out, that it doesn't really matter which one, just as long as you do them properly. So in this round, let's get rid of our x's. So I'm going to rewrite the 4x plus 3y equals negative 28. 5x minus 6y equals negative 35. So to get rid of our x's, I need to find a multiplication fact that 4 and 5 share. That's 20. So I'm going to adjust both of these so that my x's are 20. My top one's going to be a positive 20 and my bottom one's going to be a negative 20. So the top I'm going to multiply by 5. The second equation I'm going to multiply by a negative 4 so that we get that negative 20 there. 5 times 4 is 20x. 5 times 3 is 15. And then 5 times negative 28 is a negative 140. Negative 4 times 5x is a negative 20x. Negative 4 times negative 6 is a positive 24y. And then negative 4 times negative 35 is a positive 140. Let's go ahead and combine. We get 0 plus 15 plus 24. It's going to be, let's see here. That's going to give us 39y equals 140. All right, and then we have down here step 3, 39y equals, oh, actually those 140s cancel each other out. I almost missed that. So actually negative 140 plus 140 is 0. So 39y equals 0. Divide both sides by 39. And I get y equals 0, which is what we got in the first time through. So now let's solve for x, and let's see if we get negative 7 again. So I'm going to pick 5x minus 6y equals negative 35. Replace my y. I get 5x minus 6 times 0 equals negative 35. 5x minus 0 equals negative 35. divide both sides by 5, and I get x equals -7. So we did, in fact, get the same values. So our solution set is -7, 0. And I'm not going to check again because we already checked above. And we already know that these are the correct answers. Next problem, number 6. We have 3x minus 15y equals 0, and we have 6x plus 10y equals 0. They're in the proper format of ax plus by equals c, so we don't have to do anything with that. So I'm going to go ahead and rewrite them under step 2. All right, so we have where we could get rid of our x's or we could get rid of our y's. If I choose my x's, I only have to multiply my top equation. So that's what I'm going to do. I can multiply this top one by a -2 to make that a -6 so that my x's cancel out. So I get a -6x plus 30y equals 0. Rewrite the other one. Now add them. I end up with 0 plus 40y equals 0. Bring that down here. Divide both sides by 40. And I get y equals 0. Use that in my other equation. So let's see here. 3x minus 15y equals 0. So 3x minus 15 times 0. Divide both sides by 3, and I get x equals 0. So both of our answers are 0. So let's go ahead and write our solution set up here. The ordered pair of 0, 0, which is our origin on our graph, right? But let's double check. So we have 3 times 0 minus 5 times 0 equals 0. So 0 minus 0. 0 equals 0. So yes, that is correct. Let's check our other one. 6 times 0 plus 10 times 0. 0 plus 0. And we get 0 equals 0. So yes, we have done that one correctly. Number 7. 4x minus 3y equals -2. 5x plus 3 equals 2y. All right, so remember step 1 is to make sure that they're both in the ax plus by equals c form. I noticed that the second equation is not in that format, so I need to adjust the 5x plus 3 2y into standard form. So I'm going to write it right here. I'm going to flip the problem so that I can see it in this format. And that lets me know I just need to move my 5x to the other side. So I get -5x plus 2y equals 0 plus 3. So my new equation, or new version of the same equation, is this in standard form. This is what I'm going to use in step 2. All right, so I'm going to rewrite the first one. 4x minus 3y equals -2. And now I'm going to write -5x plus 2y equals 3. All right, so looking at my x's and my y's, I think I'm going to cancel out my y's. I get to multiply with smaller numbers if I do that rather than my x's. So I'm going to multiply my top one by 2, and my bottom one by 3. I get 8x minus 6y equals -4. Then I get -15x plus 6y equals 9. Add these two equations together. I get a -7x plus 0 equals a 5. And when I divide both sides by -7, I get x equals -5/7. So I end up with a fraction. All right, step 4, I'm going to take the 5x plus 3 equals 2y. I'm going to flip it around. 2y equals 5x plus 3. Replace my x. All right, so 2y equals negative 25 over 7 plus 3. I need to get rid of this fraction. So what I'm going to do is I'm going to multiply everything by that denominator, by that 7. So 7 over 1 times 2y equals negative 25 over 7 x. Almost forgot my, or no, I don't need that x. What am I doing? Take that out. We already got rid of our x because we replaced the x with that value. All right, now I need to multiply that 7 through. So I get 14y equals, that 7 cancels out with the 7 in that fraction. So we end up with just negative 25. And then 7 times 3 is plus 21. Simplify the right side and we get negative 4. Divide both sides by 14. And I get y equals negative 2/7 when we simplify it. So our solutions are the ordered pair, negative 5/7, comma, negative 2/7. Now we need to use those to plug in and verify that they are the correct answers. So 4 times negative 5 over 7 minus 3 times negative 2 over 7 equals negative 2. That gives us negative 20 over 7 plus 6 over 7. We'll get negative 14 over 7. And that reduces to negative 2, which in fact equals negative 2. So we're good on that one. Let's check the other one. 5 times negative 5 over 7 plus 3 equals 2 times negative 2 over 7. I get negative 25 over 7 plus 3 equals negative 4 over 7. All right, so let's see. How do I want to go about this? Do I want to get rid of my 7s? No, I think I'm just going to go ahead and add 25/7 to both sides. And what that gives me is 0 plus 3 equals 21 over 7. And that becomes 3 equals 3. So that is in fact correct because that 21 over 7 reduces to 3. So we have the correct answer. All right, I'm going to erase that just a little bit before I scroll up so that it's not blocking what we need to do in the next problem. Number 8, we have 24x plus 12y equals negative 7, and then we have 16x minus 17 equals 18y. We need to adjust the second equation so that it's in the proper format. So 16x minus 17 equals 18y. I'm going to flip it. And this shows me that I need to move my x to the same side as my y. And I get negative 16x plus 18y plus, equals 0 minus 17. So my new version of the same equation is this right here. Start. All right, so now we can move on to step 2 where we write our equations over here. I have 24x plus 12y equals negative 7. And then I have negative 16x plus 18y equals negative 17. I need to figure out what I'm going to multiply my equations by. I think I'll get rid of my y's. I can use smaller numbers to get rid of those, multiplying through. So let's see here. I'm going to multiply by 3 and 2, I believe. So I'm going to multiply my top by 3, my bottom by 2, or actually a negative 2, because I need them to be opposites from each other. So my top one becomes 72x plus 36y equals negative 21. Then I get, let's see here, that becomes a positive, not a negative, a positive 32. Yes, positive 32x. Negative 2 times 18 is going to give me a negative 36y. And negative 2 times a negative 17 is going to give me a positive 34. All right, so now we can cancel out our y's. 72x plus 32x gives me 104x. And then negative 21 plus 34 is 13. Rewrite that down here. Divide both sides by 104. Ooh, this does not look pretty, does it, guys? So x equals 13 over 104. But 13 goes into 104 equally, so I can reduce by 13 both numbers and at least get a smaller fraction. So x equals 1/8. That looks better than the other version. All right, so step 4, let's pick our first equation, the 24x plus 12y minus 7, and write that up here. So 24x plus 12y equals negative 7. I'm going to replace the x, so I get 24 times 1/8 plus 12y equals negative 7. 24, I wrote 28, so 24 over 8 plus 12y equals negative 7. That 24 over 8 reduces to a 3. Now I'm going to subtract 3 from both sides. I get 0 plus 12y equals negative 10. Divide both sides by 12. And I get y equals negative 5/6 when I reduce that fraction. All right, so our solution set ordered pair is 1/8, comma, negative 5/6. Okay, so let's check our answers. So we have 24 times 1/8 plus 12 times negative 5/6 equals negative 7. That becomes 24 over 8 plus 12 times negative 5 is going to be a negative 60 over 6. So that becomes 3 plus a negative 10 when I reduce those. And I get negative 7 equals negative 7. So yes, that one checks out. Let's check the second one. 16 times 1/8 minus 17 equals 18 times negative 5/6. We end up with 16 over 8 minus 17 equals 18 times negative 5 is going to be negative 90 over 6. That 16 over 8 becomes a 2 minus 17. Negative 90 over 6 becomes a negative 15. We end up with negative 15 over here, which equals the negative 15 on this side. And we are correct. Number 9, we have 2x plus 12y equals negative 7. And then we have 16x minus 17 equals 18y. All right, so this is the same problem as before, but this time through, instead of solving for y, we're going to solve for our x's. I'm going to go ahead and write that we changed the one problem to negative 16x plus 18y equals negative 17. We had done that in the previous equation, previous problem. So we don't have to go through that again. All right, so let me write these out really quickly. 24x plus 12y equals negative 7. 16x minus, excuse me, started to copy the wrong version of it. Negative 16x plus 18y equals negative 17. All right, so this time through, we're going to multiply by numbers that will help us cancel out our x's. So we're going to multiply by 2 and negative 3. Yes. All right, so that's going to give us 48x. 2 times 12 is 24y. And then 2 times negative 7 is negative 14. Negative 3 times negative 16. Actually, we need to do this by a positive 3 because we want our x's to be opposite signs. So 3 times negative 16 is going to give us a negative 48x. 3 times 18y is going to give us a plus 54y. And then 3 times our negative 17 is going to be a negative 51. Yes. All right. So that's going to give us 0 plus 78y equals, let's see here, that's going to be a negative 65, I believe. Rewrite that down here. Divide both sides by 78. I can reduce both of these numbers by 13. And I get y equals a negative 5, 6, which matches what we found for y above in problem 8. All right, let's pick one of our equations. I'm going to pick the 16x minus 17 equals 18y. And plug in for our y value to find our x value. Negative 5, 6. All right, so we have 16x minus 17 equals 18 times negative 5 gives us a negative 90 over 6. 16x minus 17 equals, that reduces to negative 15. I'm going to add 17. I get 16x plus 0 equals a positive 2. Divide both sides by 16. And x equals 1/8 when I reduce that, which is what we had found, again, above in the same exact problem. So I'm going to write my solution set here, 1/8, comma, negative 5, 6. We're not going to go through checking these again because we already checked them above. So checked above. Okay. But again, that's just to show you that it doesn't matter if you choose your x's or your y's to cancel out. As long as you follow the correct steps, then you'll get the same answers. Number 10, 6x minus 2y equals 24, and we have negative 3x plus y equals negative 12. They're in the correct format, so I don't have to worry about that. So that's good. We can move straight on to adjusting them so that we can cancel out a variable. So 6x minus 2y equals 24. Negative 3x plus y equals negative 12. I think I'm going to get rid of my y's. I'm going to multiply my bottom equation by 2. Yeah. So I'm going to rewrite the first one because that's not changing. The 2 becomes, times negative 3 becomes a negative 6x plus 2y equals negative 24. I get my x's cancel, my y's cancel, and my 24's cancel. So I get 0 equals 0. That's an infinite solution if we've done everything correctly. So remember, the way we check that is we get our equations into the slope-intercept form. So I'm going to do that just to verify. So I'm going to move my 6x. I get 0 minus 2y equals negative 6x plus 24. So negative 2y equals negative 6x plus 24. Divide everything by negative 2. And I get y equals 3x minus 12. Let's check our other one. I have negative 3x plus y equals negative 12. Add 3x to both sides. I get 0 plus y equals 3x minus 12, which is y equals 3x minus 12. So we do in fact have the same line because we have a slope of 3 and we have our y-intercept, or b, is negative 12 for both lines. So we have the same line. These equations are the exact same equations basically. So how we'll write our solution, remember, is like this, and then we'll include y equals 3x minus 12 and then the brace. Number 11, x minus y equals 4, x minus y equals negative 3. All right, they're in the proper format, so I'm just going to rewrite them. X minus y equals 4, x minus y equals negative 3. All right, so I actually don't have to change anything. I can just combine these because actually I do, because my x's have the same sign and my y's have the same sign. So I need to multiply by a negative 1 to get a different x or a different y. So that's going to give me x minus y equals 4. And then that becomes a negative x plus y equals a positive 3. I end up with 0 plus 0 equals 7. Well, 0 does not equal 7. So that tells me this is going to be a no solution problem. But we need to verify it. Let's do that quickly over here. So x minus y equals 4. I'm going to subtract x from both sides. I get 0 minus y equals negative x plus 4. And that becomes this right here. But I need to divide everything by negative 1 so that y is positive. So y equals x minus 4. Looks like it's the equation for this one. Now let's check the other one. X minus y equals negative 3. So subtract x. I get 0 minus y equals negative x minus 3. I'm going to rewrite this part. Divide by a negative 1, divide by a negative 1, and I get y equals x plus 3. All right, so let's compare our slopes. Our slope is a 1, that invisible 1. Our y-intercept, or b, is different. So what this tells me is our no solution answer is in fact no solution. We have parallel lines that have the same slope but will never intersect, so they will not share any solutions. Last two. Number 12. We have 1/3 x plus 1/2 y equals 13 over 6, and we have 1/2 x minus 1/4 y equals negative 3/4. They are in the proper format, but I want to go ahead and get rid of the fractions so we can start in step 2 without those fractions. So I'm going to write out 1/3 x plus 1/2 y equals 13 over 6. I'm going to multiply this by 6 so that we can get rid of all those fractions. I end up with 6 over 3x plus 6 over 2y, which equals, let's see, 6 times 13 is 78 over 6. Reduce these, we get 2x plus 3y equals 13. So this is what we're going to use for this one. Now let's do the other one. Same thing. So 1/2 x minus 1/4 y equals negative 3/4. I'm going to multiply this one by 4. I get 4/2 x minus 4/4y equals negative 12/4. This one becomes 2x minus y equals negative 3. So that's what I'm going to use for that one. Bring them up over here. 2x plus 3y equals 13. And 2x minus y equals negative 3. I'm going to multiply this one by a negative so that I can cancel out my x's. So I get 2x plus 3y equals 13. Negative 2x plus y equals a positive 3. My x's cancel out, so I get 0 plus 4y equals 16. Bring that down here. Divide by 4, and I get y equals 4. All right, now that we have our y value, y equals 4, let's pick one of our equations. I'm going to pick the second one, the 1/2 x minus 1/4. I'm going to replace the y with the 4 that we found equals negative 3/4. We get 1/2 x minus 4/4 equals negative 3/4. That 4/4 reduces to become 1. So minus 1 equals negative 3/4. At this point, I want to get rid of my fractions because it's going to be much easier to move things around. So I need to multiply everything by, let's see, 4. So 1/2 x minus 1 equals negative 3/4. All right, so 4 times 1/2 becomes 4/2x. 4 times that negative 1 becomes a minus 4. And then 4 times negative 3 becomes a negative 12/4. Now I can reduce my fractions. I get 2x minus 4 equals negative 3. I'm going to add the 4 to both sides. I get 2x plus 0 equals 1. So 2x equals 1. Divide everything by 2. And I get x equals 1/2 for my value. All right, so I'm going to write that up here for my solution set. I have 1/2, comma, 4. And now I just need to check them. So 1/3 times 1/2 plus 1/2 times 4 equals 13/6. So I get 1/6 plus 4/2 equals 13/6. That gives me 1/6 plus 2 equals 13/6. I'm going to go ahead and subtract my 1/6 from both sides just because I noticed they already have common denominators, and it'll help me simplify this down a little bit. So 0 plus 2 equals 12/6. 2 equals 12 divided by 6 is 2. So we are done with that one. So it actually works out. Now let's check this other one. 1/2 times 1/2 minus 1/4 times 4 equals negative 3/4. So 1/2 times 1/2 becomes 1/4. Then we get a minus 4/4, which reduces to, or when we do the subtraction, becomes negative 3/4 equals negative 3/4. And we have verified that we have the correct values. Last one. We have decimals here. And remember, the easiest thing to do is to get rid of those before we actually start the problem. So I'm going to do that. I'm going to write 0.5x plus 3.4y equals 13. I'm going to multiply that by 10 because the furthest right place value is the 10th place. That gives me 5x plus 34y equals 130. So that's our new version of that one that we'll use. The next one, we have 1.5x minus 2.6y equals negative 25. I'm also going to multiply that one by 10 because, again, the highest place value to the right that we have is the tenths location. So multiply this by 10. I get 15x minus 26y equals negative 250. And that's our new version of that equation. All right, so let's write them over here. 5x plus 34y equals 130. And then I have 15x minus 26y equals negative 250. All right, so I'm going to multiply my top equation because if I multiply it by a negative 3, I'll end up with a negative 15, and I can cancel out my x's. So I get negative 15x. Negative 3 times 34 is going to be negative 102y. Negative 3 times 130 is going to be negative 390. And then I'm just going to rewrite the other equation because we're not changing it. All right, our x's cancel, so I get 0. Negative 102 plus negative 26 is a negative 128y. Negative 390 plus a negative 250 is a negative 640. Rewrite that down here. All right, I'm going to divide both sides by negative 128. And I get y equals 5. All right, use that in one of the original problems to find my x. So I have 0.5x plus 3.4 times 5 equals 13. 0.5x plus 3.4 times 5 is 17. Subtract 17 from both sides. I get 0.5x plus 0 equals negative 4. 0.5x equals negative 4. Divide both sides by 0.5. And I get x equals negative 8. All right, so let's write our solution. We get negative 8, comma 5. Now let's check them. 0.5 times negative 8 plus 3.4 times 5 equals 13. 0.5 times negative 8 is a negative 4. 3.4 times 5 is 17. And we get 13 equals 13. So we're good on that one. Let's check the second one. 1.5 times negative 8 minus 2.6 times 5 equals negative 25. 1.5 times negative 8 is a negative 12. Negative 2.6 times 5 is a negative 13. And that gives us negative 25 equals negative 25. So we have, in fact, done our problem correctly. Let's read our quote. Once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. Arthur Conan Doyle. All right, guys, I hope you're having a great week. I'll see you in the next video. Bye.